Hi, welcome back to our series on robotics with Arduino. I am Jason Vasalio, and for this experiment, we will be controlling two servo motors using an accelerometer. Alright, so for the objectives of this experiment, we have to control the angular displacement of the robotic arm using accelerometer, to create a computer program and user interface to display data coming from Arduino. Alright. So the materials that we will be needing for this experiment will be the breadboard, servo motor, jumper wires, Uno board, and accelerometer. For this experiment, we will be using two servo motors. Alright. So again, the servo motor that we will be using will be still the same, which is the SG90. And the accelerometer that we'll be using will be the MPU6050. And we will be utilizing the VCC pin, ground pin, the serial clock, and the serial data. And right here is the Uno board, which is the microcontroller that we will be using for this experiment. We will be utilizing the pins 9 and 10 for the pulse width modulation of your Arduino for the servo motor, and the pins A4 and A5 for the I2C communication. Alright, so for the schematic diagram of the accelerometer, we have right here, as you can see, the servo motor, the two servo motors, which are connected to the pins 10 and pins 9 of the microcontroller, and their positive and negative terminal is connected to the ground and 5 volts of the Arduino. And for our accelerometer, which is the GY1 that you can see on the right side, is the accelerometer where the VCC is connected to the pins 1 and the ground is connected to the pin 2, and the A5 and 4 is connected to pins 3 and 4 respectively. So for the circuit assembly, we have right here the same thing that you saw in the schematic, except in a picture diagram. So as you can see, the servo motor is connected to the ground and the VCC of the Arduino, and their data pins is connected to pins 9 and 10 of the microcontroller. And for the accelerometer, as you can see, the SCL and the SDA is connected to the pins A5 and pins A4 respectively of the Arduino, and their VCC and ground is also connected to the Arduino. Alright, so for the programming and demonstration, for the next part, you will see the sped up version of me coding, as well as the circuit assembly using the Fritzing and assembling the actual circuit. Alright, so after that, you will see the demo, the actual demo. Alright, so now I have finished coding the entire program for this experiment. Now let me walk you through the entire program as usual. So as you can see here, we have 4 preprocessors. The first one is the Arduino.h, which is of course for Arduino framework. Now the next is MPU6050, which is for our accelerometer, MPU6050. Now as you can see here, we have a couple of functions, 2 of which will be used in our program. The next is the servo.h, which will be required for controlling our servo motors. And the last one is the wire.h, which is responsible for the I2C communication between the Arduino and the accelerometer. The next thing are the classes. We created new objects in these classes. The MPU6050 class we created a new object called MPU. Now for the servo, we have created a new object in that class called servo motor or servo 1 as well as servo 2. Now for the setup, as you can see here, we have wire.begin. Now that will initialize the communication, the I2C communication between the accelerometer and the Arduino. The next is the MPU.begin, which is the new object that we created, which will initialize the accelerometer. The MPU.gyro offsets will calculate the current state of the accelerometer, which will be needed in calculating the next states for changing the angle of the gyroscope or the accelerometer. Now the next two will be the servo 1.attach and the servo 2.attach, which is where our pulse width modulation is connected to in our Arduino pins 10 and 9 specifically. So for our actual loop, we have here the MPU.update, which will update all of the readings in our accelerometer, both in the X, Y, and Z axis. The next one will be the servo.write. As you can see, we used the map function as well as the get angle Y. So for the servo 1, as you can see, we have a range of negative 90 to 90 degrees, which you can see right here, and converted it to 0 to 180 degrees. Now, the negative 90 at 90 degrees is not the highest nor the lowest limit that the accelerometer can reach. But for simplicity and so we can control it better, we created we limited this to negative 90 and 90 degrees. Alright. So the same is for the servo 2, except it's for the x-axis. Alright, so with all of that, let's now try to upload this to our microcontroller. Alright, so upon uploading in the microcontroller, it's also important to hold our accelerometer in place for it to calibrate. So once the calibration is done, the program will be ready to execute. So let me just reset the Arduino. Let it calibrate for a few minutes. Alright, so as you saw, the servo motor already moved. That means that the calibration is done. Alright, so if I turn this to the right, you should see the servo motor or the arm turning to the right as well. If I turn this left, you should see the arm turning left. Alright, so let's test this out. Now, as you can see, the servo motor is functioning properly. Now let's try the other servo motor, which is for this arm. So if I turn the accelerometer forward, you should see this going up. You should see the arm going up. And if I turn the accelerometer downwards, you should see this going down. Alright, so let's test that out. So as you can see, the accelerometer and the servo motor is working properly. So the servo motor is copying the orientation of this accelerometer. Okay. So let's test that out one more time. Alright, so now that I have finished coding for both of the graphical user interface as well as the microcontroller, let me now walk you through both of the codes. So as you can see right here, we have 4 new lines. So the first line is a serial.print map MPU.getAngleY, negative 90, 90, 0, and 80. which is the same. This is the same as the servo dot right, except we will be printing this in our serial communications. As you can see also here, we have also printed the angle X, but we placed a dot in the middle of the two values so that we know which one is the angle Y and which one is the angle X. Now, if we go to our graphical user interface code right here, I finished the design, and for our code, as you can see, we have opened the serial port 1 and created a new function called D1 for the data. So right here, as you can see, we have created a new variable called delim, which stands for delimiting, which is a character for our delimitation. So what this does is it will split two strings that has this delimiting factor. So for example, if we inputted 80.80, where 80 is the X, or 80 then 1.100, where 80 is the Y and the 100 is the X, then what this program will do is that it will split those two values because of the delimiting factor, which is the dot. Alright. So, for you to see that in action, let's actually start this program. Alright. So, as you can see here, we have the graphical user interface. Now, if you will see right here in the microcontroller as well as servo motor, the servo motor is at a straight line, and that straight line is approximately 90 degrees, as well as this arm right here, the tiny arm right here, is at 90 degrees. Now, if I turn this to the right, as you can see, servo 1, which is this one, becomes 178 or 79, 180 degrees approximately. If I turn this to the left, hold on. If I turn this to the left, it becomes around 0 degrees approximately. And this is because the way that the servo motor is configured is that this one right here is a 0 degrees, and this one right here is the 180 degrees. Now, same concept for the other arm. So if I put this down, if I put this downward, place this downward, the accelerometer, you will see that the servo 1 actually, the servo 2, not the servo 1, this is a typo. The servo 2 becomes approximately 180 degrees. Now if I turn this up, it becomes approximately 0 degrees. And same concept, this is because the servo motor is configured to have the 0 degrees right here and 180 degrees here. Alright, so that will be it for our experiment. See you on the next one.